Hello everyone, I am honored to be able to share our work. My name is Haoyue Yang, from Tongji University. The title is H infinite need following consensus of multi-agent systems with feeding channels on the switching topologies, a semi-Markov kernel approach. The contents are as follows. Part 1 is background. A multi-agent system specifically refers to a group system composed of multiple autonomous individuals, and its goal is to complete specific tasks through mutual information, communication, and interaction among individuals. For example, a block of birds, a school of fish. Compared with the single-agent system, multi-agent systems has the following advantages. First, performance tasks and that cannot be performed by a single-agent system. Second, complete tasks with higher performance and lower cost. The third one, higher robustness and greater fault tolerance. There are many applications of multi-agent systems, such as formation flight of aircraft, reconnaissance, search and rescue, environmental monitoring of ocean, UAV parade performance. It is well known the topology among agents may change due to the external environment and other factors. The semi-Markov switching topology has the following two characteristics. The first is multimodal topology graph. The second is the random switch among different topologies follows a semi-Markov process. Some special physical phenomena, such as reflection, refraction, diffraction, may occur during the transmission of a signal, which will result in the loss of signal energy and lead to channel fading. And channel fading may result in the degradation of the signal quality, thereby deteriorating the desired performance of system. This also shows that it is meaningful to study channel fading effects for multi-agent systems. Part 2 is problem formulation. Consider a linear discrete-time multi-agent systems as equation 1, adopting a switching signal gamma k to describe the topology switching among agents. Gamma k represents a discrete-time semi-Markov chain. Denote the matrix pi tau as the discrete-time semi-Markov kernel. In this paper, we assume the channel fading model among agents can be expressed as equation 3. Based on the channel fading model, we design a distributed consensus controller as equation 4. Next figure shows the block diagram of multi-agent system with channel fading in this paper. Define a consensus error as delta ik. Assume that all channel fading are identical, then one can get the closed loop system as equation 6. Then the control objective of this paper are as follows. Part 3 is main result. We first analyze consensus and H infinite performance. And several 1 formulate a set of conditions to ensure the consensus of the system. Further, by constructing the Lyapunov function and using the stochastic analysis technique, theorem 2 denies the controller gains and obtains the sufficient conditions for ensuring the existence of controller gain. Based on the basis of above results, considering the semi-Markov kernel of switching topologies are incompletely available. Correspondingly, theorem 3 gives the controller gains delay and sufficient conditions for ensuring the existence of controller gain for the above case. Part 4 is simulation example. Given the switching topologies and fading variables parameters, first, The fading and the interference from leader to follower are not considered, and the condition of server 2 is reduced and simulated. Then add the fading and the interference from leader to follower and simulate again. The obtained state response curves are showing figure 3. Further, for the case considered in server 2, by solving the conditions of server 2, we can get the controller gains. The state response curves of each agent are given as figure 4. Figure 6 shows the norm squared responses of data IK on the two different scenarios. Table 1 and Table 2 gave the comparison of H infinite performance in this paper and consensus performance with existing literature, respectively. According to the simulation result, it can be concluded that the controller design in this paper is more general and effective. And the part is conclusion. Summary include 3 points. First is establishing a fading model based on discrete semi-Markov switching topology. Second is deriving new sufficient criteria to ensure the mean square stability and H infinite performance. And the third one is solving the H infinite data following consensus problem in the case of incompletely available semi-Markov kernel. Future work, the game optimization problems for heterogeneous or higher order nonlinear multi-agent systems are interesting topics. That's all for my sharing. Thank you.